Producing a healthcare professional requires more than the successful transfer of data. It requires the development of clinical judgment, the ability to make decisive, high-stakes decisions under pressure. For over a century, the primary vehicle for this education has been the lecture hall. This model relies on a broadcast system of passive observation, creating a significant physical and cognitive gap between the instructor and the student. The core inefficiency of this workflow lies in how it consumes the most valuable resource, in-person classroom time. Using these hours for basic information delivery forces students to attempt the most difficult part, complex clinical problem-solving, entirely alone at home. Taking notes on a demonstration is not the same as practicing it. This passive model fails to build the active, critical thinking skills that live clinical practice and medical emergencies demand. The flipped classroom addresses this by inverting the entire workload distribution of the medical curriculum. Students complete foundational learning, including video lectures and reading assignments, independently before they ever step foot in the room. Offloading the basic broadcast of information frees the physical classroom to function as a high-stakes application lab. The evidence supporting this shift is extensive. Meta-analyses of 46 studies tracked over 9,000 participants across medical, nursing, and veterinary disciplines. Objective data shows students in flipped classrooms consistently yield significantly higher theoretical and composite scores than those in traditional lectures. This success is explained through Bloom's taxonomy. Pre-class work addresses the lower-tier cognitive goals, basic recall and understanding. With base knowledge secured, instructors dedicate contact hours to the top tiers, the application, analysis, and evaluation of complex clinical scenarios. Moving lectures out of the classroom creates a scientifically validated workflow, optimizing a student's cognitive load. This foundational structural shift is particularly vital for the rapid development and long-term mastery of complex procedural skills. Data confirms a statistically significant advantage in practical skill scores, as the model guarantees the supervised repetition required to build professional competence. The flipped model forces a behavioral change, shifting students from isolated passive listeners to active participants in peer-to-peer collaboration. This active format results in measurable psychological improvements, including higher self-regulation and increased intrinsic value for the material being studied. Removing the standard lecture results in a documented decrease in student boredom and disengagement compared to these traditional, rigid formats. Centering students in the learning environment builds the self-efficacy and professional confidence required to handle live patient care. Aggregate data confirms that the traditional lecture is an inefficient, outdated tool for building modern clinical competencies. Medical and health science programs must treat physical classroom as a premium space for active application rather than a broadcast studio. Shifting to a flipped active learning curriculum provides the necessary environment to produce capable, decisive healthcare professionals.